Hey everybody, it's Mr. Clausen. Just wanted to give you some practice here with how to fill out this worksheet, the one that's dealing with the Lewis structures and ionic charge practice. So hopefully you've already got the notes on how to draw a Lewis dot structure or a Lewis dot diagram. But let's take a look at how we would put that into practice. So you'll need your periodic table handy to help us out a lot with this. The first one, they already have kind of filled out a little bit for us. It's dealing with the element of sodium. And since sodium is in group 1 of the periodic table, that means that sodium has one valence electron. Why is that important? Because if we draw the Lewis diagram for this, or the Lewis dot structure, all we need to do is put in one dot for that to figure out what's going on. Now, the next part in this column, this L1, I'm just going to kind of scribble that out to help us figure out why were we talking about this, is it's asking what would the atom do in order to have a complete valence shell. So if we remember back to what we learned is stable for electrons, or for atoms, they want to have 8 valence electrons around them. 8 in their outer energy level is considered to be a stable configuration. And so if we take a look at sodium here, what it's going to have to do, if it wants to fill this outer shell, it's either going to have to try and find 7 electrons to fill in all those gaps, or it has an option where it could just get rid of this one lone electron, then exposing all the electrons that were in the energy level below this. And so it's much easier for sodium just to get rid of one electron than it is for it to find 7 more. So what we'll say here is we say that sodium is wanting to lose one valence electron. And if sodium loses one of its negative charges, that ends up making sodium have a positive charge overall. So it started neutral, it loses a negative, meaning now it has more positives. Okay, let's take a look at the next one, beryllium. Beryllium is located in group 2 of the periodic table, so it's going to have 2 dots, and it does that because it's got 2 valence electrons. Now, much like what sodium was, beryllium's looking to get 8, so it can either try and steal 6 from somewhere else, or it could just lose those 2 outer electrons to make itself a lot easier. So in this case, it's easier for beryllium to lose 2 electrons. Now, if beryllium, just like sodium, loses some negative charges, what's that going to do? It's going to make it have a positive charge, but it's going to have not just a positive 1 charge. Since it lost 2 of them this time, it's going to have a positive 2 charge. 2 lost electrons, 2 positives. Okay? Let's take a look at chlorine. This one's a little bit different. So find chlorine on the periodic table. If you haven't looked, it's over kind of on the right side there. And hopefully what you notice is it's in group 17. So what does that mean chlorine has? It means it's got 7 valence electrons. And so the dot structure for chlorine is going to have 7 dots around it. Just a reminder, 1, 2, 3, 4 on each side first, followed by 1, 2, 3, partnering it back up. Okay. Now, for chlorine, it's a little bit different than it has been for the other 2. If we take a look here, chlorine doesn't want to try and get rid of all these electrons because it's almost got all 8 to begin with. It only needs 1 more. It's only missing 1. So what that means for chlorine is it would rather gain a single electron. It's going to be much easier for chlorine to try and gain an electron to complete that outer shell. Now for chlorine, what that means is by gaining an extra negative charge, it's now going to be a negative ion. So it started as neutral, but by gaining the negative electron, it ends up getting negative. Now, often the mistake that students have, or just even I'll do this sometimes, we think, okay, it's gaining something, so we want to say that it's going to make it more positive, because positive we often associate with, gaining. We're getting more of it, so it's in the positive direction. But you got to remember, what are we gaining? We're gaining negative charges. So in this case, if you gain a negative, it's going to make you more negative. If you lose a negative, it's going to make you more positive. All right? Okay, let's try one more here, and then you can always just check the answer key for it. It's sulfur. Sulfur is in group 16, so it's got 6 valence electrons. The dot structure for sulfur would be 1, 2, 3, 4, 5, 6. You can put those holes wherever you want. You can leave, the partnered up ones wherever you want to. It doesn't matter. But if we take a look here, sulfur is just looking to gain 2. If it could just gain 2, life would be good for sulfur. So sulfur is going to gain 2 electrons. And just like we did before, by gaining these negative charges, it doesn't make you positive, it actually makes you more negative. So since it's gaining 2 negatives, it has a -2 ionic charge. All right, so that's how you fill out this sheet. This is the sheet that we have here for practice. What you need to keep doing is just keep on going down. I have posted an answer key on Canvas. Do note, though, there is a mistake on the answer key, and so you might need to, I put in there that if you find it, I'll give you a prize for the person who's able to find it. If you have any questions on this, look at the additional resources that we have on the Canvas page, and otherwise, I will see you all when I see you.